Hello? Hey, there we go. Oh gosh. Bad, bad, bad. Hello once again, everybody. Even though there's nobody here. That's fine. It's fine. It's fine. Let's open up Visual Studio Code and see what there is to be seen. Oh, this is a different project. Switch folders here. Open folder, there we go. Blah, blah, blah. I was goofing around with a Twitch bot the other day. Okay. I need to figure out why my mouse cursor is always in black. Real quick, if there's a way to highlight my mouse cursor. Highlight the mouse click. How to get a mouse pointer highlight. That's a thing I don't want to download because that looks sketchy. Mouse pointer yellow highlight. Settings. Ease of access. Cursor and pointer, maybe? Oh, no, mouse, here we go. No, that's not what I want. No, that's not what I want. I'm trying to figure out how to highlight my mouse pointer so it's not black. It's showing up black for some reason on the stream when I have it set to contrast. How to add a yellow marker to my mouse pointer. Nah. It's not really worth figuring out right now. Okay. Where were we before? So, where we left off before, so this was our output, and we could detect scan codes, which is pretty neat. But now we need to figure out which key is being pressed whenever we detect a scan code. So I'm going to open the page on OS Dev about PS2 keyboards, because it has all the scan codes that I need. So here it is right here. Okay, so we are using scan code set 1 right now. I could change it to use number 2 or number 3 or something like that, but 1 is fine for now. Seems to be the easiest. So it looks like just about every key on the keyboard and its release uses a different scan code, except for some of these down here that are things like the multimedia keys or the keyboard keys or the number pad or something like that. They all get prefixed with this E0. Let me up my quality. Hang tight. Oh, I can't while I'm streaming. Can I? But anyway, they all get prefixed with these E0 commands, even on the releases. So the place where we are detecting these scan codes is right here. So we are printing a scan code out whenever it gets hit. So if I run it, and I'll show you. Here's our output. And if we hit keys, you'll see it fires the interrupt and prints out the scan code number. So now all we got to do is interpret this based on our lovely table here and get the right key out. So in most cases, you want to do as little as possible in your interrupt routines. So I'm trying to decide if it's best to just, in this keyboard callback function, do the interpretation right there, because this keyboard callback function is the function that gets fired when the interrupt happens. And you generally want to return out of those as fast as possible, because while you're in there, your CPU cannot handle any more interrupts. So if something else happens at that time, then it's not going to get serviced because you're busy inside another interrupt call. So I'm thinking what we need to do is we need to set up some data structure of some kind outside of the interrupt function where we can store the bytes that are coming out of the keyboard controller and then just have it do it there. So in the same way, kind of the way we did with the system clock, where we've got this time data struct statically outside everything that will retain all its values no matter what, I'm thinking we need to do something similar with the keyboard data. Right? And so we can use keyboard H to maybe define something. So what I'm thinking is, because scan code set 1 is the easiest, and the only modifier scan code that we get is this E0 number sometimes, we can just use that to keep track of 2 separate states. So if it gets, where's an example here? So like this one right here, this is the cursor up, that's the keyboard up. When you hit the keyboard up key, it will send an E0 and a 48. But if you get just a regular old 48 on its own, that's just the number 8 key. So we need to be keeping track of whether or not we have just received an E0 first or not. So if we get an E0, we'll know to switch into this other mode to interpret the number differently. So if we get just a 48, we know we're hitting the 8 key on the number pad. And if we get an E0 first, then we'll switch over to say, okay, well now a 48, if the next scan code is a 48, it is a cursor up pressed. So we can just keep track of two different modes, I suppose, or table modes to use. I don't know what to call that necessarily. But yeah, so scan code set 1 will be the easiest because E0 is the only modifier. Down in scan code set 2, it's also sometimes got this F0 modifier, which would just make it more complicated. But I mean, we could do the same thing, but keep track of 3 different states. So an unmodified state, an F0 state, or an E0 state. But I don't really want to do that right now. It's also because my keyboard setup is defaulting to use scan code set 1. You can change it, but I don't really want to do that right now. So we're just going to go with scan code set 1. Maybe later we can do an option to change it or do something else. I don't know. But not really important right now. So I guess what we should do is in our keyboard.h function, make some kind of struct that can hold the last couple of scan codes received, and maybe even do the calculation for us, because we'll probably want to go ahead and just define this table in memory somewhere so we can just put in a scan code and get out a key. So that's going to be really, really boring to watch, but whatever. So I guess let's try and do like the keyboard struct first. So I guess we'll do something like struct keyboard. Like it's all it's really doing is holding the last set of scan codes though. So like keyboard scan code buffer, perhaps something like that. Just a place to hold the last couple of bytes. And then we do have to keep track of whether or not we're in this modified state or not, depending on whether or not we got an E0 to start with. So I guess we can have just a regular old bool called, I don't know, modified table or something. So every time we get a E0, we'll just flip that to be true. And then once we're done interpreting the scan code, we'll set it back to false again in case the next one is not. Oh, do I not have... Whoops. I got to include the basics. When you're working with a standalone compiler, when you're working with a standalone compiler, you don't have built-in access to things like bools or integers except from the compiler, and they're not automatically linked. So I made this little H file that's just called the basics, that all it does is just include these data types: standard int, standard arg, standard bool, and stuff that I can just use. And because I keep including them so often, I just put them into one file. So there we go. So this modified table boolean here, we'll just use that to keep track of whether or not we just received an E0 as our first scan code, and to interpret the table differently that way. And if we don't, then we don't do anything with it, and that's totally fine. That's all fine and dandy. Okay. And then the rest of these are simply unsigned char scan code. So that will keep track of the scan code that we just got from the keyboard controller, or encoder. There's a keyboard encoder and a keyboard controller, and I get them backwards. The keyboard controller is what you can write to and send commands to get the keyboard to do stuff. Like if I wanted to switch scan code sets from 1 to 2, then there's a byte you could send the controller to say we're switching scan codes and start using the new one. But then the keyboard encoder is what interprets the physical button presses on the keyboard into a scan code to be read by the kernel. Or something to that effect, to be honest. So it would be really, really cool if inside this struct, I don't know if you can do this in C. I'm more of a C++ kind of guy. I'm not that familiar with C, but I know that structs are just in C++ anyway. Structs are basically the same thing as a class, except it defaults differently whether or not it is public or private. And so in structs, you can have member functions and methods and constructors just like you do a class. So it would be pretty cool if this keyboard scan code buffer struct could actually have a member function that does the translation for us and returns out a key. But I don't think that's quite possible, so we might just have to leave it as is like this. Okay. So then all we'll need to do is... So now we've got this scan code buffer struct right here. So now in keyboard C, we can just make a static keyboard scan code buffer. Keyboard buffer. Something like that. Why are you not... Oh, there you go. Okay. Wait, what? No. Why are you not... I'm including keyboard... Oh. My bad. Type def. There we go. Alright, so now... And the thing about static is it will retain its value as it's passed around. It only exists in the context of this file because we haven't made it available to anything like the kernel. So similar to what I'll have to do... Oh, maybe this isn't the right way to do it though. Because what I want to do is I want to be able to just have the kernel ask for what the last key pressed was, and I want it to already be interpreted at that point. So like if we get scan code 48, that's the 8 key, so I want that keyboard buffer to be holding something to represent the 8 key when the kernel goes to ask for it, so it's already been interpreted. So it sounds like I need to go ahead and just make a stupid huge enum for most of the relevant keys. There's a lot of them, unfortunately, but I mean, maybe we can just stick to like the alphabet for right now. Maybe just the alphabet and the numbers and the enter key, maybe. Something like that. Okay, this is gonna get really, really stupid, and hopefully you don't get too bored, but here we go. If I can type. I'm not that great of a speller, and I'm using a new keyboard too, so I'm kind of still getting used to the feel. Alright, keyboard keys. Keyboard. So let's start. Let's do this numerically down, because enums automatically, as you define them, and if you don't override them, they start at 0 and automatically define down. So like what I'm doing right here, if I think escape is first, and see if I just start defining values like this, escape is already going to have the value of 0 equated to it. And then if I do the next one, keyboard, I don't know, what's the next one? 2 is the, no, it starts at 1, doesn't it? Dang it, I should probably start at 1. But like num1, then escape will automatically have 0 assigned to it, and this one will automatically have 1 assigned to it. But since these start at 1, I need to go ahead and override this and say this guy equals 1. And I believe that if you do 1 override, then the automatic assignments just continue from then on. So now that I've assigned this guy to be 1, it will automatically start counting at 2, 3, 4, 5, 6, all the way down. But, you know, I like being verbose, so, you know, I think I might just, you know what I'm going to do? I'm just going to, no, that's not what I wanted. Not what I wanted. Copy. There we go. Let's define a bunch of these, because we're going to have to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You know, that should be the whole alphabet. So let's just start with the alphabet for right now. Keyboard A, and that does not start at 1. What does that start? Oh, excuse me. So where's the A key? Three, blah, 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 blah. Are there more down here? No, those are all modified keys. Where's the A key? A pressed, 1E, there we go. So we'll start by defining this guy to be 1E. Oops. 1E. B equals OX 30 looks like. C OX, this is going to be really boring, I'll tell you right now. It's 2E. Heck, maybe we'll only even do like half the alphabet just to see if this works. Keyboard D equals OX. Why can't scan codes be in numerical order? B, C, D, E. I know my alphabet. Most of the time. Sometimes it's hard, but, you know, we'll get through it. B, C, D, E is 12. OX, B, C, D, E, F is 22. Yeah. C, D, E, F, G equals OX. Wait, crap, was I reading that table wrong? Sorry, F is 21. That's 22. Hold on. All right. Let me go back and double check that I'm not screwing this up. This table is confusing. So A is 1E indeed. B is indeed 30. C is 2E. We see D. D is in fact 20. ABCD is 12. F is 21. Okay, yeah, I was reading that right. And feel free to ask anything if you want me to explain something. I'm just kind of going on here. This is not going to be the most exciting at the moment, unfortunately. C, D, E, F, G, H equals OX. C, D, E, F, G, H. Where is H? Ah, there it is. 23. Wait, are these actually ascending in some numerical order now? That would be nice. HI equals OX. 17. J equals OX. This table is dumb. Oh, there's a few more down here. Those are released though. Scan codes actually, there's 2 event triggers whenever you hit a key. There's actually a scan code for the key that you press down and also a scan code that happens when you release it. So that's how your computer knows, like if you're still holding down a key, it can just wait for the key up release to know that you've stopped hitting the key, and that's how your computer knows to like jam a bunch of keys out, or just like to, if you hold it down, to start doing a whole bunch until you get the release scan code to know that you have released the key. So actually every single one of these keys has a unique release scan code as well, but I don't think that's really necessary to keep track of at the moment. Maybe it will be for something else, but I don't really care. So where was I? J. J is 24. K equals 25. Okay, I think they're actually mostly progressing numerically now. J, J, K, L. Hey, it is. There we go. So 26. Oh, X. 26. J, K, L, M. C, H, J, K, L, M, N equals O, 3, 2. N equals OX, 3, 1. That's a backward step. H, J, K, L, M, N, O equals OX. 1, 8. P equals OX. And O. P is 19. Would be Q. OX. OX. Q. Ah. 1, 0. QR. A, B, C, D, E, F, G, H, J, K, L, M, N, O, P, R is 13. QRS equals OX. QRS is 1F. Oh. QRST equals OX. We'll get there. We're almost there. It's 14. QRSTU is OX. QRSTU is 16. QRSTUV is OX. I just saw it. 2F. There we are. QRSTUV W X Y Z. OX. So we're a W. 1 1. O. Man, this new keyboard's kicking my butt. It's 2D. Y is 15. And Z, I just saw you. Where are you? 2C. There we go. So there's our basic alphabet. And you know, I really... No. Should I type def this? Yeah, I'll go ahead and type def it for right now. See if it needs to be type defed. If it makes it any easier. Okay. So now, that's our table. So now, all we gotta do is match whenever we get a scan code jammed in, decode it with this. Actually, is this even the... Yeah, because I can't map it directly to a character because that would be... That wouldn't work. Yeah, so it's going to be a two-step process. So it's going to be matching the scan code to our table we just wrote. And then it's going to be matching these keyboard key types to an actual character to display. So when it comes time to actually printing out characters, we'll want to go, okay, a keyboard A equals, the character A. Print that. Because we couldn't just do, like, for example, we couldn't just do this OX1E. That wouldn't, like that right there, we can't just do that. Because that's two values. You can't set two values equal to each other. So it has to be a variable in between. But okay. So let's use this. Okay. So let's get rid of this, or at least move out of the way, this print statement that happens whenever we get a key pressed. And we want to take a look at it. So maybe we should go ahead and make a special key in here as well for the key, for that keyboard toggle bit, which is E0. Toggle, maybe. That'll... Here, let me E0, like that. Yeah, so we've got something to map to that too. So if our char scan code that we get in is this keyboard toggle bit, that's where we'll go and set this modified table boolean to be true. And so the next scan code that we get will be modified. Seeing as how we didn't make any of those modified keys in our table at the moment, though, we don't really need to care about that. So instead, we don't need to care about that at the moment. So right now, all we need to do is do keyboard buffer dot scan code, equals scan code. Like that. Right? So we'll say, so the scan code comes in as an unsigned char, right here. And we can just save that directly into our keyboard buffer data type. And then when we go to interpret it, we can just see if it's equaling any of these, because these will be the same thing. So now we can do a check to see. I guess we could go ahead and do the check right now. So if scan code equals, no, we don't want to do a type def here because then we have to make an instance. No, I just want this to be a straight up comparison table. There we go. So if this equals keyboard toggle, like this, keyboard buffer dot modified table equals true. Like that, see? And we didn't make this an else. Like so. Okay? So now we have Is that what I want? Is that what I want to do? Yeah, I think that's what I want to do. Yeah, so if it's not that special E0 key or E0 scan code, we'll just save it just as is. Is there an easier way to do this? Because I'm trying to think about too how we're going to get the actual character out. See, I don't want any of this keyboard interpreting code to reside in the kernel. I want it all to exist here. So I'm trying to think what the smartest way to get the physical character that was typed out to the kernel. I just want the kernel to be able to request the last key or the most recently typed key. You know what? Let's not even make this scan code type even hold a scan code. Let's just have it hold the actual character. And this doesn't even need to be called a scan code table anymore. So we'll just do the interpretation. Oh, no, that's not what I want to do either, though, because I said I wanted to spend as little time as possible in the ISR. Okay. Yeah, we'll make it 2 steps. So I know what we'll do. Well, so in our new function, that the kernel is allowed to call to get the next key, we'll have it do the interpretation there and just pass the correct character over. Yes, that's what we'll do. Okay, so I'm going to make a new function, so it's going to return an unsigned char get last character, like that. Why are you not? Oh, okay. This is Visual Studio Code I'm using, but it's really kind of freaking out because it doesn't have any library path because this is a standalone compiler. I think it gets really confused sometimes. Just randomly decides that stuff isn't defined. Yeah, okay. So we're just going to have to crank out a bunch of if statements here. So if... so if keyboard buffer dot scan code equals keyboard A, return A. Like that. See, so now the kernel will be allowed to call this get last character function, and in here we'll do the conversion from scan code to character, and to be sent. Oh, that reminds me, I got to define this in syslib. Extern unsigned signed char get last character. So syslib, for now anyway, until I make it smarter or better organized, syslib is the place where functions that the kernel is allowed to call will reside that are defined in other places. That's why they all have this extern keyword on it. So extern is just promising the compiler that it's going to be defined somewhere else, even if it's not included. See, if I were to include keyboard.h, or actually like CPP, actually, that'd be kind of silly too. But if I were to have, yeah, that wouldn't work. But if I were to have this get last character prototyped in the keyboard.h file here, then if I were to include that h file into syslib.h, then I wouldn't need to do this extern keyword, because the compiler would then create a copy of it to be compiled along with it. But since I'm not doing that, the extern is just saying, I'm telling the compiler to trust me that it's going to be somewhere else in one of the other files that you compile, and that it just needs to be patient and wait until it shows up. Yeah, so this is the one function that the kernel will be allowed to call, which is get last character, which is what we're working on right here. So, in fact, maybe I'll just implement one or two of these and see if we can get it to work, actually. Yeah, keyboard B. Actually, well, these are all going to be else ifs. Yep. Scar code, scan code. Return B. Else if keyboard actually, for following good convention, I'm actually going to switch these. You might be asking, why the heck am I switching these? It's to prevent my own error, any human-induced errors from getting in the way. So when you do a assignment operator, which is the single equal sign, which is to say I have a variable and I want it to equal this value, that actually returns a true or false, whether or not it was possible to do. And so if I were to accidentally forget an equal sign right there, well, here, let me put it back and I'll show you. If I were to have it like this, see, if I were to have my variable on the left and my constant value on the right and just one equal sign, then when I get to this statement here, what it would actually do is it would try to assign keyboard A into this variable and then return whether or not that was actually possible or not. And so this would evaluate to true because it would be able to do that. And then it would jump inside here, and then it would all be messed up because I just overwrote a value, and I'm now in the wrong if statement. But if I switch these around to have the constant value on the left rather than on the right, see, for an assignment, this is backwards. You can't say, I have a constant value, and I now want to assign it to a variable. So if I were to forget that second equal sign to do a compare instead, it would catch me because then you can't, because it can't do an assignment with the constant value on the left. So it's a good convention to do. Actually, it's a good thing to do for like Booleans also. If this were to be if I were to have a Boolean, if true equals variable, this would fail. If I just wanted to check if the variable is true, then this would be possible. But if I were to skip or forget one equal sign like that, that would not compile. The compiler would stop me. But if I were to have those two values, or those two things reversed, then this would actually compile because I can set the value of true into that variable and it would move right on. So it's a convention that I like to follow to protect myself from my own spelling mistakes, which are quite frequent. Hello, welcome. So anyway, where were we? Oh yes, we were decoding scan codes. So I'm thinking we might just try these first couple of keys right here and see if we can just get these couple to work and just not be careful not to use any other keys that are not implemented yet. Scan code. Return C. And then we'll have the final else, because it's always good to have else's. We'll just have it return D. So if it's any other key that I have not implemented besides A, B, or C, it will return D. Like that. Okay? You know, it might be good to... Oh, and then we'll want to zero out the buffer too. Because then if we're going to be calling this really, really fast and we don't empty out the buffer, it'll just return like A's as fast as it can until we zero it out. So we do actually want to go in every single one of these and set our scan code back to 0. And then we'll also need to come up with a way to protect whether or not there's actually a new key. Because once we have the key return out of it, like my plan here for right now is in the kernel. This is down in the kernel. At the very bottom, I've got this infinite while loop. Hello, welcome. I've got this infinite while loop, and so my plan for right now is to just call this get last character function inside there, but we only want it to. No, we shouldn't have it return 0. We should have it return, or we shouldn't have it return D. We should have it just return 0 for right now. As a byte. And then I guess we'll just, for right now, just to see if this works, we'll have to do a check in the kernel to make sure it's not a 0. Yeah, it'll work for right now, just for prototyping purposes. So now, I want to put... Oh, do I not have that available? I have standard I/O. Print char, that's what it is. Oh, maybe I should have it return a pointer to a char. Huh. This is just prototyping. I just want it to work. I just want it to work. So print char just literally pops a character onto the next location on the screen. So I wonder if I can just do get last character. I don't think that'll work because I'm not reporting. I'm not But no, it is a pointer to a char. A char literal. When you feed it in, it copies it by memory location. So that might actually work. Actually, no, I don't want to do that right there though, because I want to check first to see if it's a 0 or not. So if does not equal, oops. Oh, and I don't want to call get last char here either, because every time I call it, we zero it out. We zero the value out. So what the smart thing to do would be, just for right now, unsigned char temp equals get last character. So now we've just got a hold of what it is. Like that. Temp. Whoops. Stupid new keyboard. Grr. Stop trying to help me. Temp. Print char temp. So like that, okay? So is that what I want? So in this while loop, as fast as possible, we are going to look at last char. And if last char is currently not 0, we're going to print it out. And it only works for A, B, and C for right now. So I really, really wonder if this is going to even work. So let's give it a build and try. Make clean, make all. Oh my good gracious. Oh, my bad. These need to say enum. Right? No, they don't. So like this. This is low-level C. If either of you guys, anybody knows how the right way to do this, I can't just call that. It's not recognizing this enum. Be keyboard encoder. Is it not like that? That might be a C++ thing. How am I allowed to use that? Oh, because I defined it at the bottom. Silly me. It's not created yet. There we go. Oh, I'm going to switch this around too. Let's try that instead. Makes a pointer from integer without a cast. Yeah, so that's where that... Oh, well, what if I just make this an unsigned char pointer? Initially from makes integer with the... Oh, man, now it's complaining about that. I guess I can cast this. Is that going to work? This may or may not work. Nope. To an integer of different size? No, it's not. This is returning an unsigned char. Get last character is returning an unsigned character. What if I... I'm still learning kind of when it comes to throwing memory around. So what I can and can't do may or may not be maybe questionable at sometimes. Cast a pointer from integer of different size. Well, I just got rid of that, so what was the error again? Make all. Makes a pointer. So initialization of an unsigned char pointer, which is right here, from an unsigned char, which is what this is returning. No, that wouldn't. No, I knew that wouldn't work. C doesn't really have references. Huh. What am I trying to do here? Let me go look at print char. That's in print C, I believe. No, it's not. It's in VGA controller. That's a terrible, terrible place for it. That's a horrible place for it, actually, but whatever. Yeah, so it takes a const char pointer. Oh, and this doesn't care about it. It's also complaining that I'm trying to pass in a char of different signedness. So really, I think const or print char here should take an unsigned char. It really should. Where is standard IO? I gotta change it in here too. Oh gosh, man, that was not smart of me. I made it. Now that affects another function down the line. Fudge, should I just go fix all that then? That's in my printf function. Let's see. Unsigned. Yeah, so I make these all... I guess I should just make these unsigned. Because they're having to do with printing out characters, and there are no characters that have a negative sign in ASCII. So, it shouldn't matter that I... Well, plus the thing is, too, ASCII characters only go up to like 150 some odd or something like that. I can't remember. Well, no, that's not true, because an unsigned char holds up to 254. So a signed char is up to 128. I think half that. And so characters, ASCII characters, like from a keyboard, are only in a range from like 30 some, I don't remember, it's like 30 some odd to like 1 in the teens or something like that. So you would never get to a point where you would even need the negative or the final bit, the most significant bit. So it doesn't actually really matter, I suppose, if you're dealing with characters, whether it's signed or unsigned, because your characters would never get into territory where the sign would actually matter. Right? Yeah, I think. But oh gosh. Okay, yeah. So I'm not gonna worry about that for right now. I guess I'll just make get current char return a, or get current character return an unsigned. No, make get last character a signed character, because it's not gonna hurt anything. So I'm just gonna get rid of that. Let's make sure we're back to crap. What did I forget? Oh, yep. Get rid of that. Okay, we're back where we started. So I will just, for now, again, for now, because this is all... So I will make get last character just a regular old char and not care about sign this for right now. And... oh, because I'm storing it in an unsigned char too. So just a regular old char pointer. Hopefully that gets rid of that error. Okay, so I got rid of that error. So now this only error that we have here is I can't seem to figure out how to get a pointer, a char pointer. Casting it didn't work. Of different size. How is that a different size? Error. The error is cast pointer from an integer of different size. Well, that's not true because it's popping out a char, which last I checked was the same size as a char. Cast a pointer from integer of different size. Well, a char pointer, I mean, pointer addresses are, I think they're 32 bits, but a pointer is still a pointer, so it... So like this char pointer temp right here, that should be a 32-bit value, I believe, because that's holding an address. And then when I cast... Oh, just for fun here, what happens if I make get last character return an int? Because those are 32 bits. It's incompatible. Yeah, I haven't got there yet. Calm down. Ah. That's a really hacky way. All right, so here's our output. So let's see what happens. Well, that's not what I wanted. That's A. That's B. And that's C. That's not what I wanted at all. But it is not advancing for any other key. So that means our check of 0 is working. You guys see that? So if I hit A, we get a white space. If I hit B, we get a black space. And if I hit C, we also get a white space. See, so those are those. But if I hit other keys, like K, J, I, O, space, we are not advancing. So that means the value inside get last character is popping out. Just for fun, instead of that, let me just go ahead and print out the integer the ASCII number of the character. So if I do printf d space what's a pointer? Dereference temp. Get the thing stored in temp. That worked. Okay, so here we are again. So if I hit A, oh my, -44. Oh, maybe signedness does count. Okay, B is getting a 0 for some reason. And C is getting -16. Something is seriously wrong here. Just for kicks and giggles, unsigned. Let's put it back to unsigned again, see what happens. Starts up over here. I gotta bring it over here, show you guys. 212, 240. That was C. B is still 0, so I don't know what's going on with B. Just for fun, let's see what happens if I actually print the of different signedness. Oh man. Yeah, so print char again is looking for a signed input. Pull up an ASCII table real quick. Okay, so the letter A should be decimal number 97. And instead, it's printing out 200 and some odd. Let me table that for right now. Oh, wrong direction. There we go. Table that for right now and just do a regular old assigned char temp equals get last character. And just pop that straight out. See, yeah, it's not a pointer anymore, so let's pop that right out, see what happens. Okay, here's our output. The letter A. Hey! 97. Is that what I was supposed to get? Where's my table? That is what I'm supposed to get. B is 98. C is 99. That's exactly correct. Okay. So that's good. So can I just cast it to a pointer? Just to be put into print char? I should really go back and redo print char to see if it really needs to be unsigned or not. Or if it really needs to be signed or not, I suppose. Where'd my music go? Yes, I'm still watching. There we go. Thought I wasn't watching. Okay, so that's pretty neat. So it's successfully decoding the scan code into a character. That's pretty freaking awesome. Okay, so now let's go ahead and just leave that as is for right now. And can I just cast it into an assigned pointer? Maybe? Signed char pointer? I don't know if that's going to work. Nope, it did not like that. Cast pointer to integer from different size. So addresses, I believe it's complaining that addresses are 32 bits long and a char is only 8. And so when I try to cast to a pointer, it's complaining that, hey, you're trying to turn an 8-bit number into a 32-bit number. So maybe instead... Oh, well, what if I just create a new char pointer temp2. Don't ever do this. This is terrible. Equals the address of temp. Is that allowed in C? Okay. So create a pointer to the char variable that I made. Oh gosh. And give that to print char. Right? This is very bad. Don't ever do this. No! Char from pointer targets initialized from char from unsigned char of different signedness. I realize that though. I want it to be... Does this have to be signed? Does that need to be unsigned? Whoa! Look at that! It's an A! There's a B, and there's a C! No other keys work because of the code coming back is 0 for those. C. Oh my gosh, that's so freaking awesome! Backspace doesn't work either. Backspace is a special case where we'll have to do something special to have it actually move the cursor back one and replace it with a blank spot. That's how backspace is going to have to work in effect. But anyway, let's go implement some more keys. So that's done in keywords. That's just right here. So I guess let me just copy this. C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. So, A, B, C, D, E, F, G, H I and this isn't even getting to deal with like holding down the shift key. So maybe eventually that keyboard scan code buffer struct that we made will also need to hold a special spot to know if modifier keys have been added, like things like control or shift, for example. J, K. Oh. L M N O P Q. I should probably commit some of this pretty soon. Q R S T U V W X Y Z, and just for good measure I'll do the spacebar too. I don't have one for space yet, but I'll make one. Space. Let's see, so up here in our scan code table, we'll have one for space, which is, let's go back to our, oh gosh, nope, not that. Our PS2 keyboard table here. Enter's another one we might want to do too eventually. One is escape. Space, 39. Okay, so at the very bottom, if we get a space bar, we will print just a blank space like that. Okay. Here we go. Let's see what happens. My name is Zane. Oh man, that's so neat. No yeah, so it doesn't know if I hold down shift. It just types a regular. Backspace doesn't work either, too, so I guess we'll have to think about how to do backspace next. Yep, I'm going to go and commit some of this. Git status. This all has to do with keyboard-based stuff, though, so I guess I can do it all in one commit. Add all. So, keyboard got basic keyboard support working. A scan code lookup table. That's that enum that we made. And ASCII translator. Yeah. Cool. That's really awesome. I'm going to push it too. Actually, do I want to update the README? I'm going to go ahead and check off keyboard support. Add the README. Git commit. Updated README. Okay. Come on. Android. Ah! Can't type, evidently. Cool. It is official. Is there anything else I want to work on right now? I don't know how long I've been going for. Almost an hour and a half now. Yeah. I think I'm going to go ahead and call it there for tonight. Still practicing this whole streaming thing, so I thought I'd start kind of small. But thanks for tuning in. Really appreciate you hanging out with me while I work through this. And yeah, I'm going to start doing this a little more often probably, so maybe I'll see you here again. But thanks for watching. Bye.